So in our first hour, we talked about some equations that were kind of complex with the parentheses. This hour, we're going to talk about some that are complex in this way. What's different about this equation than what we've seen before? There's no parentheses, but there's also x squared. Now in this one, if you look really close, the x squared is not a factor. Can you tell me why? Yeah, well, on each side we have a 3x squared. I have to get rid of one of them, so I'm going to subtract them. Well, since it's the same on both sides, if I subtract 3x squared from one side, I subtract 3x squared from the other side, and they're both gone. Leaving me with 14x plus 35 minus 4x. Over here I have 4 plus 30x minus 15. At this point, we will not learn, in fact, in this class, we will not learn how to solve equations that have x squareds in them. They're called quadratic. What we've done so far with just x is what you call a linear equation, and that's as far as we're going to go as far as solving equations in here. So for us, every time we see an x squared in an equation, there better be some way to get rid of it. Well, there will be some way to get rid of it, put it that way. So here the x squared is gone, the 3x squared canceled out on each side, subtracted out. What would be our next step? Yeah, 14 and negative 4x make 10x. We still have the positive 35. On the other side, what are we going to end up with? 30x minus 11. Good. Then what? Factor 10x. So 35 equals 20x minus 11. And then at 11, 46 equals 20x. This one might start to look familiar right now. And then divide by 20 gives us 2 3/10 equals x. Or 2.3 if you wanted to put it as a decimal. It should say at the end in parentheses, it'll say expressed as a fraction or expressed as a decimal. Usually it says right by the answer box. It'll tell you to express as a decimal rounded to the nearest hundredth or express as an exact fraction or whatever. So here, tell me what to do. Subtract x squared. And it is gone on both sides, which, as we said, is a good thing because we can't do anything else if it doesn't. So we have negative 3x plus 7 on the left, and we have 5x minus 17 on the right. What is next? Add 3x. So 7 equals 8x minus 17. And then add 17, giving us 24 equals 8x. And then 8, 3 equals x. Here's one for you to try in your notes. Okay, talk me through it. First step. It's a negative 2x squared, so we're going to add 2x squared. Luckily, when we do the same over here, that one's gone too. So what do we have left? 7 plus 3x plus 2. Good. Okay, and what's next? Okay, so over here, 7 and 2 make 9. So 3x plus 9 equals 5x minus 12. And then subtract 3x. 9 equals 2x minus 12. And then add 12. 21 equals 2x. And then divide by 2. 10.5 equals x. Or 10.5. Again, that's 21 divided by 2. You can write it as just 21 over 2. Goes in there 10 with 1 left over. Any questions? A slightly different version of that would look like this. So here we have the parentheses. Now the first set of parentheses has nothing to do there. So that's just x squared minus 3x plus 7. There's nothing to do there. Second set of parentheses, distribute the negative 1. So negative 1 times x squared is negative x squared, or negative 1x squared if you want to put it that way. Negative 1 times negative 4, positive 4. Still equals 7. Then what? Well, x squared and negative x squared cancel. 1 plus negative 1 is 0. Then what? The negative 3x. 7 and 4 make 11. Now what? Subtract 11. So negative 3x equals negative 4. 7 minus 11 is negative 4. And then divided by negative 3. X equals now negative 4 divided by negative 3. Negative divided by negative is positive. So it would be positive 4 over 3, which reduces to 1 1/3. So x is 1 1/3. How do you feel about those? I'll give you that warm and fuzzy feeling inside. Yeah. What about when we encounter something like this? What would be our first step? No, not run away screaming. Add 3/4. There we go. So 2x equals 6.5 plus 3/4 is 7 1/4. Then what? Divide by 2. Good. X equals, well, 7 1/4 divided by 2. I have to make this into an improper fraction. 7 times 4 is 28, plus 1 is 29/4. Now instead of dividing by 2 over 1, I'm going to multiply by 1 over 2. So this is 29 over 8. 8 goes into 29 3 times with 5 left over. So x is 3 5/8. That should look kind of familiar, right?
Yes.
Good. What do we do when we hit something like this? Well, we had a couple of options. The first option was to look at x over 3 and read it as 1/3 x. Then x over 2 becomes 1/2 x. So now, just like having, 5x plus 7x equals 36, here I would add 5x and 7x to make 12x. Here I'm going to add 1/2 and 1/3, or 1/3 and 1/2 to make 5/6x. 1/3 plus 1/2 is 5/6. Then you keep the same name of x. What would we do next? Divide by 5/6. So x equals 18. Okay, where'd the 18 come from? Well, 15 divided by 5/6. If I think of that as being 15 over 1, it becomes 15 over 1 times 6 over 5. Cross-canceling the 15s to give me 1, or 15 and 5 to give me 1 and 3. 3 times 6 is 18. 1 times 1 is 1. So it's 18. But there was a second option. And we're going to stress the second option right now because there are some equations we're going to hit where this second option is the only way to solve it. We could look at these fractions and look at the denominators, 3 and 2. What is the least common multiple of 3 and 2? In other words, think least common denominator. 6. Okay? So I can multiply this whole equation, every piece of the equation, by 6. So here, this is going to be 6 over 1 times x over 3. Well, we will cross cancel. 6 and 3 cross cancel. Both divisible by 3 to give me 1 and 2. 2 times x is 2x. 1 times 1 is 1, so just 2x. Positive, so 6 over 1 times x over 2. 6 and 2 cross cancel to give me 1 and 3. 3 times x is 3x. It's positive 3x. 1 times 1 is 1, so it's just 3x. Equals, what's 6 times 15? 90. So now, 2x plus 3x makes 5x equals 90. And of course, now we simply divide by 5. X equals 18. To a lot of people, that's simpler to do because the fractions go away. Now, I see some confused looks out there. Questions? Does everybody see where the 6 came from? Okay. So I'm going to give you one to try using that method of getting rid of the fractions. So go ahead and try that one in your notes. Figure out what you're going to multiply by to get rid of the fractions. And we'll go over it in a second. So what are we going to multiply by? 35. Good. So this will be 35 over 1 times x over 7. And of course 35 and 7 cross cancel to give me 1 and 5. So that makes 5x. This will be 35 over 1 times x over 5. And of course, 35 and 5 cross cancel to give me 1 and 7. So 7 times x is 7x. So plus 7x equals 24. From there, 5x and 7x make 12x. Oops, what did I forget to do? You got it. 35 times 24 makes 840. So now 12x equals 840. We divide by 12 to get that x equals 70. Now again, we could have solved this by making it 1/7 x plus 1/5 x equals 24. But the reason I showed you this method of multiplying by that common denominator is we're going to run into equations where we cannot do that. Those equations will look something like this. Here, of course, the big difference is the variable is in the denominator. It's on bottom. The only way we can solve this is to get that variable off the bottom of the fraction. And the only way to do that is to use that common denominator. We have denominators here of x, 6, and 3x. So for the numbers, we can think of it as a 1, 6, and 3. What's going to be the common denominator there? 6. Very good. For the variables, we have x. What's the highest power? 1, or just x. So we're going to multiply this whole thing by 6x. So 6x times 3, that's simple. That's just 18x. 6x times 2 over x. Well, this is 6x over 1 times 2 over x. And what cross cancels is just the x. 6 times 2 is 12. Next, we have 6x times 5 over 6. So 6x over 1 times 5 over 6. What cross cancels there? The 6. Leaving us with x times 5, or 5x equals, over here, 6x. So 6x over 1 times 5 over 3x. Cross canceling there will be the x, and 3 and 6 cross cancel, leave 1 and 2. So 2 times 5 makes 10. I'm going to pause there. Any questions on where those numbers came from? Okay. So, next step. You got 18x and 5x make 23x. Still have the plus 12, plus 10, and then subtract 12. 23x equals negative 2, and then we're going to divide by 23. Very good. So x equals, what's negative 2 divided by 23? It is negative 2 23rds. I know that seems like you're cheating, but it works. I'm thinking you guys might want to see one more before you try one on your own. Good intuition there. Okay. Let's see here. So let's take a look at this one. Actually, I'm going to do this. Maybe it'll make it work better. We'll see. Looking at this one, we have denominators 2x, 3x, 2, and 6. So just looking at the numbers, we have 2, 3, and 6. Common denominator will be 6. For the variables, we just have x. That's their highest power, so it's 6x. So I'm going to stop there. Questions on where the 6x came from? How many of you think you can find the 6x? And doing it on your own. Okay. That's a start. So now, 6x times the 7 over 2x. So 6x over 1 times 7 over 2x. What'll cross cancel? Now, is anybody having a problem cross canceling these? Because if you have to, you can just do this. 6x times 7 is 42x. 1 times 2x is 2x. Dividing that out, 42 divided by 2 is 21. The x's divide out. That's perfectly fine to do that. So now we have the 6x times, now this is a negative 5 over 3x. So that means down here in our answer, this is going to be negative. Positive times a negative is going to be a negative. The reason I'm putting that negative down there is because it would be very difficult to deal with it if I left it up in the fraction. So now this is 6x over 1 times 5 over 3x. We've already accounted for the negative down here. So I can multiply it out like I just did here, or I can cross cancel the x's. And 6 and 3 cross cancel to give me 1 and 2, which gives me a negative. 2 times 5 is 10. So negative 20, or minus 10. What would be next? 6x times 1/2. So 6x over 1 times 1 over 2. The 6 and the 2 cross cancel to give me 1 and 3x, of course, is still there. So 3x times 1 is 3x still. So it's plus 3x. Equals 6x times 11 over 6x. 6x over 1 times 11 over 6x. What's going to happen there? 6x cancels out. We get 11. Perfect. And then 6x times 2 plus 12x. Very good. Now what? Combine what we can. On the left side, we get 21 and negative 10 make 11 plus 3x equals 11 plus 12x. What would be next? Subtract 3x. So 11 equals 11 plus 9x. And then subtract 11. 0 equals 9x. And then divide by 9. What's 0 divided by 9? X equals 0. I know that wasn't very nice. In your notes, just to see how it's going. Try that one quick. Start it off. What's our common denominator going to be? 10x. Very good. So now 10x times 4, 40x. Good. Then we got to do the 10x times 6 over x. So 10x over 1 times 6 over x. What happens there? X's cross cancel. 10 times 6 is 60. Positive 60. And then 10x times 2/5, so 10x over 1 times 2 over 5. What happens there? 10 and 5 cross cancel to give me 1 and 2. And of course, there's still an x there. 2x times 2, positive 4x. Equals, over here we have 10x over 1 times 3 over 2x. And what happens there? X's cancel. 2 and 10 divide to give me 1 and 5. So 5 times 3 is 15. Then what? $40 plus 4x is 44x. Plus 60 equals 15. And then subtract 60. 44x equals negative 45. And then divide by 44. X equals negative 45 divided by 44 is negative 45 over 44, or negative 1 and 1/44. What do you think? Nobody's screaming yet. That's good. No tears. That's really good. So maybe we step it up a notch. What's going to happen here? Common denominator will be 45 won't quite work for 6. So how do we find that if we don't see it right away? Do you remember the process? Do factor trees. So we have 15, 9, and 6. When we're looking for that least common multiple or least common denominator, remember we factor using powers. Well, 15 is just 3 times 5. There's no repeated factors. 9 is 3 times 3, but we're going to write it as 3 squared. 6 is just 2 times 3. So now our least common denominator or least common multiple is going to be all the factors. We have 2's, 3's, and 5's. And the highest power. What's the highest power on the 2? Oh, just the 1, so just 2. On the 3 is 3 squared. On the 5, there's no power, so it's just the 5. 5 to the 1. So this is 2 times 3 squared is 9 times 5. Multiplies out to 90. 90 is our least common multiple, or least common denominator. So this is going to be times 90. So, oops, that's not what I want. Different color. 90 over 1 times 4x plus 3 over 15. I want to put this in parentheses for a very good reason. 90 and 15 cross cancel to give me 1 and... What's 90 divided by 15? 6. We still have to distribute through this parentheses with the 6. 6 times 4x, 24x, and 6 times 3, 18. Now this negative here could give us nightmares. What I'm going to do is before we multiply by the 90, I'm going to multiply the negative 1 through the top here. So that's actually going to be a negative 2x plus 6 over 9 times 90 over 1. Now here when we cross cancel, the 9 and the 90 divide out to give me 1 and 10. Very good. Is that? Oh, that should be plus 3, shouldn't it? I don't know where that 6 came from. There we go. Sorry. 10 times negative 2x. Negative 20x. 10 times a positive 3. Positive 30. Now equals, on the other side, 90 over 1 times 6x plus 4 over 6. Well, once again, the 6 and the 90 give me 1 and 15. We're going to multiply 15 times 6x, 90x. 15 times 4, positive 60. And finally, we have 90 times 3x, which is 270x. You can see already this one is stacking up to be loads of fun. On the left side, what do we combine? 24 and negative 20 make 4x. 18 and 30 make positive 48. On the other side, what do we get? 90 and 270 make 360x plus 60. And then subtract 4x. So 48 equals 356x plus 60. And then subtract 60. Negative 12. 48 minus 60 is a negative 12 equals 356x. And then divide by 356. X equals a negative 12 over 356. Now the negative can go with the 12 or it can go up front. It doesn't matter. Both of those can be divided by 4. So that's negative 3 over, what, 89? That's it. Negative 3/89. What do you think? Oh, don't scowl at me. It's not that bad. Ready for the sharp stick? Yeah. Well, the good news is that's all the damage I'm going to do for tonight. So, you do have a new quiz due tomorrow, which is Friday, at 11:59 p.m. You do have a new homework due for next Tuesday. Of course, these are both in my math lab, so back to them. Huh? With that, again, I have the computer lab is open here next door if you want to get started on your quiz or your homework. Your next test is going to be a while. Let me take a look here. Yeah, it's like November 5th is what it looks like. Yep. November 5th.